calculate is area between two curves. By curve, the curve could technically be a line, and it could be a parabola like in this case. So you guys have one in orange, which you guys can see. Can you guys see my arrow when I'm pointing on my, I think you guys can, right? You guys see my arrow when I'm pointing like right here, like the orange curve? Okay, thank you. So the orange curve is your linear equation. Notice that it's written in terms of in terms of x, y equals x plus 4. And your other function being y equals x squared minus 2x is in black. And so what we're doing is similar to Riemann sums, where you guys are summing up. So imagine when you guys were in geometry, you were limited to being able to find the area of geometric shapes such as trapezoids, circles, squares, rhombus. So those things were we were limited. And so the idea of calculus being able to find the area between any two curves is an idea that goes back to Riemann sums, where instead of summing up perhaps only two rectangles, so if I only had two rectangles here, we can see that top minus bottom of the height of each one of those rectangles times the width is not going to do a very good job of estimating the area that we want, which is between the two curves. So what we do is we increase the idea of the number of rectangles that we have to an infinite amount. But when we first start off with this, we think of it as a representative rectangle. So usually what I'm going to have you guys do is when I say draw a representative rectangle, I want to see like a rectangle that is one of these rectangles that you guys see here. I'd like to see just one of the rectangles represented on your graph, just because then that way you guys know, well, the width of each one of these rectangles is a small change in x, it's dx. And the height of the rectangle is going to be determined by the y values of the top function minus the y values of the bottom function. So understanding that the orange function is always going to be above the black function, the parabola. And if I take a y value that is on top of another y value and subtract the two, I should get a positive height and not a negative height. So understanding the orientation of this rectangle being the height is represented by the top minus the bottom, and the width is dx. Okay, and that comes up with our formula that we're going to eventually use, but I just wanted to show you guys, eventually, if we were to go up to, let's say, 500, you can see that the area between the two curves, which is what we're trying to achieve, pretty much looks like the picture with 500 rectangles pretty much looks like what we want. And so the idea of going out to infinity means that we're eventually approaching the actual area of it. So here is an example of a pretty basic one. So what's going to be entailed in all our problems is we're going to want to know, when does the first rectangle occur? And these are going to provide us with our limits of integration. So you guys can see a is -1 over on the left-hand side. That's to denote when does my first rectangle occur? That's going to occur at x equals -1. And notice that that's the intersection point of the black and the orange. Over on the right-hand side, you guys have the second intersection point occurring at 4. And so we're going to integrate this from -1 to 4. When I was looking at my representative rectangles let me make it smaller so you guys can see actual rectangles. When we look at the actual rectangles itself, notice that the change in x is what will determine how my integrals will be structured, whether it's going to have vertical rectangles like we do here, or eventually horizontal rectangles. Okay, so dx means that everything's in x. My limits of integration will be in terms of x, -1 to 5, or sorry, to 4. So here's another example. I made up these functions and I thought, okay, well, if they, and sorry, it's kind of messed up here because I couldn't figure out how to do the partitions, but I just wanted you guys to see, if you guys were given a function that's a little bit more complicated, what you're going to do is ideally find the area between curves. Well, between curves would mean just this middle section right here would be one of the sections. And then what we do is we figure out what that area is, and then we add it to the area that you see on the right. Ignore that little purple part right there. So that orange part right here, what just big picture wise, we need to find the intersection points of these two functions. So if it's not going to be something that we can do by hand, which a lot of these problems are by calculator, that means that involves finding the intersection point here, finding the intersection point here, and then the third intersection point somewhere above there. And also recognizing that the orange section, you guys have the pink section in the middle. You have the top function being the cubic function minus the parabola, versus over on the right-hand side, that purple section is going to be the parabola minus the cubic function. So we have to set up 2 separate intervals for that. So we're going to do a problem similar to this one. And then lastly, what happens if I have a function that looks like, or technically these aren't functions here. The orange is a sideways parabola, not a function. And so if I were to find the area using the same methodology, I couldn't figure out in time with the 2 minutes I had before class to draw the rectangles. But if you guys were to draw the rectangles up and down here, you would see that you have this top portion of the parabola being the top function, and then this being the bottom function only until this juncture. Okay, so if you guys all follow my my cursor up and down, to the left of that cursor, the area between the curve is going to be orange minus black. But if you look over to the right of that arrow that I'm drawing, or that I'm tracing, you have the top of the parabola minus the bottom of the parabola. So that's going to pose a problem if I have a rectangle going up and down. We're going to have a separate area here and then a separate area here. To fix that, what we do is we change the orientation of the rectangle so it goes this way instead. So if you guys think of, instead of top minus bottom, if we think of right minus left, now we have, starting over here, or sorry, down here, you guys can see it's going to be the orange function minus the black function. Orange function minus the black function all the way through the entire region. Okay, does everyone see that if you flip the rectangle going left and right, it's going to be orange minus black if we want a positive length of that rectangle. Okay, because the right x value is going to be bigger than the black x value. And so that just entails that we rewrite our integral so that everything's in terms of y, including my limits of integration. Whatever this y value is here is going to be my a value till this value here. And you guys, and if this is like all overwhelming, that's basically the entire lesson. So I basically walked you through the examples that we're going to do by hand. But I figured it's nice to see a pretty graph before I start to sketch these on my own. So let me stop share. Does that make sense to you guys, the kind of the concept that we're about to move into? I can have you guys type into the chat kind of or yes. And I'm going to share my screen and have you guys find the notes. Yeah, kind of would be great too if you guys can type that out so I can kind of have an idea of where you guys are at. This is not what I want to be in, so hold on, let me exit out of grades. Oh, speaking of grades, I forgot to release your test grades, didn't I? Dun, dun, dun. Okay, I'm just kidding, you guys. You did wonderful on that test, so no need to stress. That's your test. That's not what I want to be in. And if you guys didn't get a chance, I didn't do the scoring guide or present the scoring guide to you, but the answers I did rewrite or write out for you on the homework assignment. So if there's any questions to it, let me know about it. But I think you'll have time today, hopefully, for you guys to go into the breakout rooms, start on the homework for tonight, and then talk about the homework from the previous night. Okay, so we are going to be on this page. If you guys can have your calculator out, and I'll kind of direct you guys on what's like not legal, but what you should be able to do with your calculator and what you should try to avoid doing. So the first part of the notes, it kind of talks about exploring the area between curves, similar to what we talked about. If you guys can highlight this part of it, the steps are going to involve, well, we would have to find out what our limits of integration are. And in order to do that, that's going to involve us finding the intersection points. If you think back to what does it mean for two functions to intersect, it means setting both functions equal to each other. In some cases, if it's going to be a non-calculator question that involves algebra, if it's a calculator question, you guys are going to find the intersection points on your calculator and store those values. So if you can highlight this part, all values should be stored. And what I mean by that is if there's like 3 intersection points, like we'll see in some of our problems, you're going to store it in, you know, those letter value. And actually, I don't know what color it is on your calculator, but for mine, I believe it's green. So let me erase this and put it in green instead. So those letters that you guys see on your above each one of, like, so for the letter A, it's above the math button, but you're going to store it in different variables like A, B, C. And so when you set up your limits of integration, you're going to reference these stored intersection values as opposed to writing down the estimated value and using the estimated value. So remember that. So if you're always slightly off on your problems, it's probably because you aren't doing this step correctly. Make sure you guys are storing those into your calculator as variables. Okay, so sketch a graph of 2 curves and draw a representative rectangle. I described that, but we'll do that together. And then our first few problems are going to be setting up the integral and recognizing what that representative rectangle is, whether it's going to be horizontal or vertical. Okay, so in this next question, it's always going to say bounded by, which means that you want the curves to surround the entire area. Okay, they should intersect in some way. And if they give you guys boundaries that are vertical lines, you want to account for those as well. Okay, so the first one, find the area of the region bounded by the graph y equals x squared plus 2. So y equals x squared plus 2, we know is a parabola shifted up 2. So if I can have you guys go ahead and sketch that for me. And sometimes all it is I just need to know what function is on top, what's on bottom. So that's going to be green, the other one's going to be red. The next function that I want to do is y equals negative x. So go ahead and sketch that as well. And you guys can see as you're sketching this that something's missing. These functions are not intersecting. Normally they are. So I would say most problems they will intersect. If they don't, look at what else is provided to you guys. Okay, so if I look, they also provided you guys vertical lines as boundaries of this region. So you also want to take that into account. So we have x equals 0 and x equals 1 also as the boundary. Okay, your representative rectangle. So the region is will be shaded here in between. Okay, that's going to be the region that they want. And then your representative rectangle could be a single line. Okay, so what you guys are trying to do is if you look at, actually, maybe you guys should look at mine before you draw a rectangle. So if you're trying to decide which direction should I go in, should I go right minus left or top minus bottom, horizontal versus vertical. If I draw a representative rectangle, I'm trying to get the right color here. Not too big. Okay, so no, that's not going to work. Okay, purple. We're going to do purple instead. Okay, if I draw a rectangle here, that little purple length right there is a rectangle. You guys can see it's blue minus red. But when you move over here, it's blue minus blue. And then up above there, it's blue minus green. That's going to be way too messy. For each one that changes right minus left functions, you're going to have to set up a different integral for it. So we know for sure we're not going to want our rectangle to go in a horizontal direction. So let's do vertical. Okay, so representative rectangle, you guys can actually draw in a rectangle if you like, or you guys can just draw a line. And what you're recognizing here is that that rectangle, if you were to start over on the left-hand side, rectangle over here is blue minus red. The rectangle that I drew is, green minus red. And then the rectangle that I drew is also green minus red, all the way through from 0 to 1. So this is true from starting at 0, it's green minus red, all the way through to x equals 1. So that's the one that's the direction I'm going to want to go in. So the way that we find the area, and I would like you guys to say a of x to recognize that your representative rectangle is going to have a width of dx, that everything, your integral is going to be in terms of x. So a of x, so my integral is in terms of x, and we're going to want the x value as limits of integration. The first being 0, we start off left to right. So x equals 0 is going to be my first rectangle, and then moving all the way to 1. So x equals 1. Then we're going to have the top curve being the green curve. So if I do the green curve, the equation of the green curve was x squared plus 2. So x squared plus 2, this is my top curve. And then we're going to subtract out, we're trying to find the height of this, subtract out the red curve, which was negative x. Okay, and all of this is top minus bottom. This is going to be representative of the height. And the dx part, which is, it really just tells you guys with respect to, but it also represents the width of each one of the rectangles that you guys are summing up. So from there, we just integrate. Okay, so simplify first. I encourage you guys to simplify your inside of your integrand, the integrand first. So x squared plus 2 plus x dx. Go ahead and find the antiderivative and evaluate that for your definite integral. Okay, you guys, can you type into the chat one that did not make sense to you, 2 kind of made sense, 3 made sense? 3 is you understand it. Okay, not very very similar to Riemann sums where you guys are doing rectangles here, but now we use integrals to find the actual area. Okay, between a 2 and a 3 is what we're seeing, which is what I would expect with the first. So the height serves the purpose of representing the height, the dx, but it's just part of your integral to tell you that it's with respect to x. So you don't do anything with that. You just integrate term by term each one of the values within your integrand that is the top minus bottom portion of it. All right, you guys, the next one, we have 2 minus x squared, and y equals 2 minus x squared. And you guys also have y equals x. So let's go ahead and graph. And this time I think I'll use blue, whatever I have available here. So blue and purple for my curves. So notice that this time you guys only have 2 equations here. So that means that these 2 functions should intersect, and they should, you don't need the boundaries that were provided to us at the beginning, like x equals 0 and x equals 1. So we will see that they intersect. You just need a rough idea of what the graph looks like. So upside down parabola, negative x squared, shift it up 2. And if I wanted to be exact, I could come up with these values as well. So the 5 key points of that parabola. So that's going to be in blue. And then go ahead and sketch y equals x in a different color. And let's say, I mean, I drew a pretty darn good graph there, so I can tell what my intersection points are, not to brag or anything. But if, let's say, you guys couldn't tell because your parabola, maybe the way that you drew it, you couldn't tell, or you don't know if it's exact, why don't you guys set the 2 functions equal to each other? So it involves finding intersection points algebraically sometimes. So finding intersection points, I do want to show this to you guys. That means that you're going to set the 2 functions equal to each other algebraically and do things like a factor if you need to. So I'm going to add the x squared, subtract the 2 to the other side. So x squared plus x minus 2 equals 0. If we factor this, and I know some of you guys do guess and check, which you should be able to do at this level. You're just figuring out what times what is x squared, x times x, what times what is 2 or -2, it's 2 and 1. And you have to decide where the signs go such that if you were to FOIL out the middle, you would get 2x minus 1x is going to give you the 1x that's in the middle here. Okay, so x plus 2 and x minus 1. So go back to your graph. Does that make sense? That sure does. It intersects at x equals -2 and x equals 1. Draw a rectangle. So you guys are going to draw a representative rectangle somewhere within your graph here. And you guys can play around with that. You guys, if yes or no on this one, if I draw a horizontal rectangle, would it be just 2 functions that I need for that? Yes or no? If you drew the rectangle the other direction, what do you guys think? Could you draw the rectangle going the other direction and it just be two functions that you need? Okay, so what I mean about that with that question is if I were to draw the rectangle going in this direction, the red going in this direction, it'd be pink minus blue from the bottom here all the way up to right there. Okay, and right at that point, you would have the right of the parabola minus the left of the parabola being a separate interval that we have to set up. So we're not going to want to do horizontal, but if we do vertical, if I start on the far left as my A value, all the way through, it's always blue minus pink. And so you want the easiest one to do, which is going to be that vertical direction. So go ahead and set up your interval and then check to see if you guys get the same interval. Ignore my screen, it jumped to a different page. Yes, I get that question a lot. So thank you for asking that. Someone said, can I draw the representative rectangle anywhere? And that is true. I just want you guys to draw one rectangle somewhere within the region, just so that you guys start to recognize that, okay, well, that's going to give you my orientation of dx. That's a small change in x, that's the width, and that's going to tell you guys your area should be in terms of x. That's all that rectangle is doing. It's just getting a visualization of what you're doing. I'm okay, by the way, if you guys get 2 problems on your homework assignment, for you to, at this point, when you're just evaluating, so I want you to go through setting up top minus bottom. By the way, I've had kids on the free response before. I'll mention it now, I'll mention it again. They'll skip this part of the setup of the integral. So that where I have the arrow right there, this part of it always accounts for at least 1 point of your free response question. Do not skip over this just to provide a decimal approximation, because most of these questions will be on the calculator section. And when they are, sometimes if it says find the area between 2 curves and you guys get really good at this, you might just think, okay, I can just do top minus bottom on my calculator, set it all up, and then write the decimal answer. That's gonna only give you guys partial credit. So please make sure you guys set up the problem. Now, if it's a calculator question, the next step would be the answer. So you would have this set up, and then next step, answer, whatever the decimal approximation is. You're not integrating by hand. If it's a question that you can integrate by hand, you can integrate by hand when you can integrate term by term, in which case we can on this problem. And so once you guys get to this point, just for the purposes of your homework assignment, and you can use your calculators to evaluate if you want all the fractions that are involved. I'm okay with that because most of the times this ends up being on the calculator section anyway. But please make sure that you guys are finding antiderivatives, getting that practice in, and then if you do have a calculator question that is, or sorry, on a multiple choice non-calculator section, which it is possible that you would have a question like this, then you are practicing that finding the antiderivative part, because I don't want you guys to kind of get forget that skill as well. So go ahead and type into chat once you guys input that into the calculator, come up with an answer. What did you guys get for this area? Oh, and by the way, area now should always be positive. Area should always be positive. And if we don't have a positive area, oh, wow, I just got 3 people put in 3 different answers. So if you guys can double check, the correct answer is 9/2. 9/2. So I'll give you guys a minute just to double check again. If you didn't get 9/2, maybe where you guys went wrong with that. It could have just been evaluating the fraction, but first check to see if you guys have the correct antiderivative. Did you plug 1 in and then did you subtract? -2 plugged in. So double check that. I'll give you guys a moment. And then if you guys actually could practice, if you got 9/2, can you guys practice checking your work? So if this was a calculator question, from this step, you guys would use math and then integral, which is 9. And then can you input this in and see if you can check your work and see if you guys get this answer as well. So once again, as you guys are checking your work, if it is the calculator question, you can't possibly find the intersection points algebraically, you had to do it on a calculator. All of that would be done, including the intersection points, by your calculator. Store those values. You would input this into your integration functionality on your calculator and then output the answer. You would not need to show all these steps in between. Same with derivative questions that you had on the calculator section. I'm kind of prepping you guys for the final exam, as well as like if you're given any type of calculator question where you have to find a derivative or an integral, you're not expected to do those by hand. So don't try, just go straight to your calculator and then do it that way. For the ones who didn't initially typed in something other than 9/2, did you guys figure out what you did wrong, or do you guys need a little bit more time? Can you guys type in, if you are done, type yes. If you guys need more time, type in how many more minutes you think you might need to get to that answer. Just so I know I can move on, since I can't see your expressions. Okay, so I'm going to give it another minute. As I'm giving you guys that minute, just the homework assignment from the textbook tonight, you will have questions. I think when I looked back at it, I tried to go back on it last night and modify it so it's not so many problems. I think one person here already completed the homework assignment, which is awesome, but I ended up modifying it to have less problems on there. And I would like you guys to try to do these less problems without a calculator, because we're going to have a lot of free response practice with the calculator. So just like I did it above, I would expect you guys to be able to find the antiderivative of everything by hand. And it's fine for you guys to do the final calculation of fractions and arithmetic with your calculator to get that answer. That's fine with me. And the person who wanted more time, let me know if you are done or not. Oh, and if you guys can't figure something out, like if you did something on your calculator, or you're on a problem, you can't figure out what you did wrong, it helps for you guys to, I think I've said it before, but snap a picture. Like last night, I got a message about the calculator. They couldn't match an answer. They screenshotted their home screen, and I could tell right away what was wrong. So if you guys are getting something wrong, just save it as a picture and then send it to me via Remind, and I can look at it. also to see what it is that you guys did incorrectly or your work. So remember all that work you guys did last year with polynomials. No, I'm not going to expect you guys to be able to do every single problem like we're about to do, which is, graphing by hand. But what we're going to do is kind of just try to do this without the calculator up to the point where you guys have to integrate and then come up with the actual answer. You can do the arithmetic by hand, but I'd like to see if we can figure out what this graph looks like without a calculator. So let's go ahead and do that cubic function in blue. Okay, and you'll notice that you can take an X out of everything that is there. So I'm going to talk about just graphing this briefly and coming up with a really quick graph of this without necessarily all the details that you might have had to do last year. So if I factor out the X, so the purpose of doing what I'm about to do is, zeros were one of the main features of polynomials that you guys learned. So setting this equal to 0 and seeing where it crosses the x-axis. So x, and then you guys get 3x squared. Can you guys find the zeros for me and type it into the chat? If we're having trouble with factoring, let me know as well. And for the sake of some of you guys who do the X method and like a refresher on that, I'm also going to do it on the side using the X method. Don't forget to times A and C on top. Okay, good. We have x cubed, so we should expect 3 different zeros. Otherwise, there's that multiplicity as well. You guys have 3 factors here, so don't forget all 3 of those. I'm going to expand this out a little bit. This graph I know is jumping by ones here, but because of the small units and it being easier if we made these a little bit larger, can we go ahead and picture that this is -1 instead? So I'm going to jump by every 2 squares is 1, just so we have a bigger graph here. Can you guys type into the chat if you're ready for the next stage? If you're still stuck on the factoring, let me know. Again, go ahead and type yes, you're ready to move on. Or if you're still working, keep working. But if I see a lot of yeses, I'll move on. All right, you guys. So after you guys get these zeros, think back to last year when you guys thought of end behavior as well. You guys have a leading coefficient that's positive and that's cubed or odd. Okay, so if that's the case, then we're going to anticipate our the left end behavior to be pointing down and the right one to be pointing up. Do you guys remember something called multiplicity? All of these factors that you guys have here have multiplicities of 1, which means that the exponent was 1. What did that mean about what was happening at those zeros? What happens at the zeros if you guys have multiplicities of 1? And you guys saw this at the Algebra 2 trig level as well as the pre-calc honors level. Yes, very good. So if you guys have a multiplicity of 1, which each one of these factors do, if it was odd, you learned that it crossed the x-axis rather than an even one like x squared, it bounces off of the 0. So let's go ahead and sketch. If we know that the left is down, and then it crosses at -5/3, it must go back down, it must cross again, cube function 2 hills, and then it goes up on the right hand side, end behavior. So we get a nice quick sketch of what the graph looks like using that methodology without necessarily knowing what the min and the max is. Now, of course, that you guys have calculus, if you were doing curve sketching, you could find the min and max by finding the derivative, then setting it equal to 0 and finding exactly where that occurs, but we might not need it for the problem. So let's go back. In most cases, we don't. The other function that I have to graph is y equals -x squared plus 2x. So if I took an x out of this, I would get -x plus 2. So my two zeros for this one are 0 and 2. So go back to your graph. You guys have a 0 here and a 0 at 2. And remember, we were jumping by 2's. Okay, this is a upside down parabola. So I would expect that the hill occurs above here and then it goes back down. Okay, let's say, and I did this on purpose. Let's say you guys drew this graph. One of the mistakes that I see sometimes when we're doing area between curves is that you guys get like the first region, because like our previous problem, there was only one region. Okay, you have to ask yourself if this function continues to decrease on, or it's technically increasing, but if it continues to go down left of 0, and so does this blue function, what do you guys think? Do you think they'll eventually intersect? Okay, and it doesn't matter. You're not going to be graded on the curves for these. That you're not going to be expected to sketch the graphs. And in fact, most of the times the graphs are given to you guys, but I wanted you to see that at some point it's probably going to intersect. And so if we don't see that initially and we want to find out where they intersect, then what that entails is setting the two functions equal to each other and solving for the zeros of that function, right? Solving for this. Okay, so if you guys set it equal to each other and solve for it, we add x squared to both sides and the x squareds cancel out. We subtract 2x and we get 3x cubed minus 2x is equal to 0. Factor out an x. Yes, I wrote something wrong, didn't I? Negative 12x, thank you. So that means we can take out a 3x. So x squared minus 4, that would make more sense. So it intersects at 0 at plus or minus 2. Okay, look back at your graph. Does that seem reasonable? Yes, it does. It looks like those are the 3 points of intersections that I have, which I'll do in red. Okay, those are my 3 points of intersection. Okay, so thank you for correcting that. All right, you guys. So how many integrals will you need for this one, you think? How many integrals do you guys think you need? Okay, good. So you maybe you guys are typing in, you'll need 2 integrals, which is correct. The second one, aren't those colors pretty? Okay, so you have the yellow region is defined if you drew a representative rectangle on that one. Let's go ahead and draw a representative rectangle here. You guys will see that that representative rectangle in the yellow region is defined by a different top minus bottom than the region in the blue. So what we do is we set our functions, and let's say that you guys had functions defined as f of x and g of x for a problem. So you would say first, again, areas with respect to x, the width of each one of those rectangles is x. And then we go about setting up the first integral, and you guys can do it all at once. We would, if we do the yellow region, can you guys type into the chat, what is your limits of integration for the yellow region? What are your limits of integration for the yellow region? Good. Less always on the bottom. So -2 left to right, -2 to 0. Perfect. And then we have the blue function minus the pink function. So the cubic function minus the pink function. Oops, dx. Then we're going to add, this time we pick up for the blue region, starting at x equals 0 and going on to 2. And we switch the 2, right? This time your pink function is on top, or the parabola is on top, and then the cubic function is on the bottom. So you switch the 2. The top this time is -x squared plus 2x, and then minus 3x cubed minus x squared minus 10x dx. I'll only have you guys find the antiderivative once because of this one, and then just as I'm confident you guys can do that on your own. But my suggestion is please don't do this term by term as is. Please distribute and simplify a little bit before you guys find the antiderivative, and then do the rest on a calculator for me, just in the interest of time. So what I'm going to do is just find the antiderivative, or simplify first. The important part of all of this is understanding how to set up the integral is the most important. The second part is not losing the skill of finding antiderivatives. So doing that part by hand, and then the rest of it, if you guys can just make sure after you plug that part of it into the calculator that we get the correct answer. So type into the box once you guys are ready with the solution that you guys got, and we'll do our last example. Okay, good for the 2 people who've typed it in so far. That is correct. Good, still looking good. Still looking good. Those coming in. And then once I do provide the answer, if you guys can say that you have the correct antiderivative, I'm good with that. And then if you're still working on just computing that on the calculator, that's fine. I wanted to give you guys some time in the breakout room, so we're going to move on from here. The ones that I've seen so far, all right. It is 24 is the correct answer. You guys can just double check your antiderivatives and make sure that it looks like what I have. Okay, most of your AP questions on area and volume will involve a calculator. It'll involve a region that's already sketched for you. So in this example, this last example that we're doing, this is the idea of if I were to split this, and you guys don't have to shade this as of yet, but if I were to shade this part of it blue, and then this part of it, not blue, yellow, if you guys were to look at the shading that I have done, that if I were to have the integration go according to what we've been doing, drawing the representative rectangle vertical with a vertical orientation, it would involve having two different integrals for that. So two different regions where you guys have the top on the blue, the top is the line minus the bottom of the parabola or the negative square root function. And then the yellow region having the top square root function, the positive square root of 3 minus x minus the bottom, which is a negative square root of 3 minus x. So that's going to involve having two integrals. Whereas if I decided to instead think of the rectangles going in this direction, then I have just one integral that I have to set up. So in this case, it was 2 if we kept the orientation vertical. So what we're going to do instead is switch it so that it's a horizontal. So notice that what the rectangle that I drew has a width of dy, a very small change in y. The a value that I'm going to have now for my integration is the if you think about the first rectangle that you guys have, it's all the way down here, and then the last one is going to be all the way up here. So my a value is going to be this value here. So this is a equals, and then my which is -2. And then my b value is going to be the y value of this intersection. So this is y equals +1, -2 to 1. Okay, so we go from bottom to top. And if we look at each one of the equations, they gave you guys two equations. Y equals positive square root of 3 minus x is going to be the top half of your parabola. So I'm going to trace that in blue. And then the y equals -3 minus x is the purple part. It's the one that has a negative, it has a negative y value, and it's below the x-axis. Okay, so if I wrote any one of either one of those equations, and if I had to be in terms of y, that means that I have to solve for x. So with either one of those equations, that's going to involve me squaring both sides and isolating x. So if I do that, I get x equals 3 minus y squared is going to be the equation of that sideways parabola. So whether I square this one, the positive one, or the negative one, I would end up with this as my as the equation of the curve. Okay, so we're going to do the same thing for y equals x minus 1. We're going to write it in terms of y, which means that you guys isolate x. So if you isolate x, you guys get x equals y plus 1. So that's going to be your first thing, is if my representative rectangle is horizontal, everything needs to be in terms of y, including your limits of integration. So now area is going to be with respect to y, so a of y, because of the dy parts. And instead of, well, actually it's written right above that. Instead of top minus bottom, now the height of your function is going to be determined by the right curve minus the left curve. So the right curve in this case is the purple, which is the sideways parabola. We're going to have 3 minus y squared is your right. And then your left parabola is going to, or sorry, your left function is going to be the linear equation. So y plus 1. And remember, this is going to be the height of it. And this is the width of your rectangle. Okay, so it's got a horizontal orientation. And our limits of integration are in terms of y. So y equals -2 is smaller. That's going to go on the bottom, y equals 1. And then from there, you guys do everything exactly the same way, including on your calculator. So if this was a calculator question, I think that is the first source of confusion. Sometimes kids are like, oh, well, do I use the x variable or is there a y variable? So you're going to pretend y is x on your calculator. If you were doing this on the calculator, once everything's in terms of y, at this point, your y's you can view them as x's and do that problem on the calculator. But for this one, since it is easy to do by hand, you don't have to write the y equals on the limits of integration. I just did that on the first step so you guys could see. Make sure you guys simplify first before you find the antiderivative. It just makes it a little bit easier. So keep going with that and see what you guys get. And then type into the chat what you get when you guys are done. Good, Jake, that's right. Good, Andrew, that's right. If you guys have questions about the lesson, I'll show the answer in just a minute. But if you guys have questions on the lesson at this point, if you guys can ask it in the chat. Is there anything that confused you? For the person who asked, why is there two integrals for this one, there's only one integral. Is it for this question that you asked, or just like why? Oh, why on top here? Is there two integrals on that question? Oh, sorry. So that question was kind of leading you to discover that you would want to go horizontal since horizontal only has one. But I think that's the assumption because the previous examples were a vertical orientation. If we did a vertical orientation, we would have two integrals for that. So this is assuming for a vertical orientation. But if we switch over to a horizontal, then it's only one. Does that make sense? So two if we had kept it vertical. And it's not to say it's incorrect, but it would just be more work.